Hey everyone, and welcome back to the C++ data structure series. My name's Nick from Coffee Before Arch, and what we're going to look at today is a simplified version of the singly linked list that we looked at last video. So last video we made a fairly robust singly linked list. We made it handle a bunch of edge cases, but we don't always need something that's so that complicated. So we don't necessarily need to have multiple different ways to insert a node. We don't need maybe multiple ways to delete a node. Sometimes we just need something pretty simple. So in the example that we'll look at today, we'll only handle one type of insertion and then one type of deletion. So this will be a linked list that will just append something to the end of a list, end of a singly linked list, and then the deletion will just remove the last item in the list. All right, so we're not doing any kind of either head insertion, tail insertion, or position insertion, and then we're not doing any head deletion, tail deletion, or position deletion. So it really simplifies the code that we need to write. So let's go ahead and look at first our interface. So we have a slightly modified interface today. We're going to use the same node. But as far as the linked list class goes, it's going to be a lot more simple. We'll only have three methods, and that will be the add node method, the delete node method, and we'll just keep the print list. That way we can visualize our linked list at every operation. Okay, so let's go back to the implementation and see how that's simplified from our original version. Okay, so if we go to implementation.cpp, so here we have our add node. Now, our add node is very similar to what we needed for insert tail, except the only thing we really need to keep track of, or the only case we need to handle, is this one case where the list is empty. And that's where, just like last time, our tail insertion, or our add node in this case, is creating the first node in the list. So we just need to check to see if temp, which is this pointer to head, is null. That means the list is empty, and then we'll just add a new node. Otherwise, all we need to do is handle the case where we have to walk through the list and then add a node to the end of the list, which is what we'll do here. So we'll walk the list until the next is equal to null. The only list item where that will be true is at the very last item of the list, or the tail of the list rather. And then we'll just set the temp next to be the new node, right? So the previous last item on the list will now point to our new node. And that's it. We'll just print out what the list contains at that point. Then the only other method besides the print method is the delete node, which will delete the last node in the list. And again, it's very simple. We need to first check to see, of course, is this a valid deletion in the first place? So are we deleting something from an empty list? So that shouldn't be allowed, so we'll catch that with this assert. Then the next thing we'll do is, okay, it's not an empty list, so we have to walk through the list to find the element to delete, which is what we do in this while loop. So we'll constantly march along, keeping track of what the previous node is and what the current node is. Then we have two cases to handle here, which is one, the case where we're deleting the first node in the list. And in our case now, this is deleting, there will only ever be a single node in the list in this case, because again, this is tail insertion, or tail deletion rather. So the only time that this will be true is if the list is already, or the list only contains a single element. And that's the only case where this will be true, where previous will be equal to null. Okay, and so why that happens is if there's only one item in the list, that means that node will be equal to head, but head is the last item in the list. So previous will be equal to null, and it will skip the while loop completely because the heads next will be pointing to null, and then previous will still be null here. So then the other case is pretty simple. It will just, that means that the list contains more than one element, so we'll just march along in that while loop, and then we'll just set the previous next to the current node's next, and then we'll just delete whatever that current node is. And in this case, that will also delete, this will also delete head as well in this case. So this will just set head equal to null here because head is now null because this is the case where there's only one list item. So we're deleting that one list item. And then, like I said, the other case is just normal. And then we have our print list. Okay, so let's see what our simplified example will be. So if we go to singly linked list.cpp, we'll only have a couple things here. So we'll just loop over, and because we only have one type of insertion, we'll just add 5 nodes with add node. And then we'll just delete 5 nodes here using the delete node method. So let's go ahead and compile this. So we'll do g++-c on implementation. And then we'll do g++-o on singly linked lists. And then, implementation.o. There we go. So let's see what we get. Right. So pretty simple. Let's zoom out a little bit. There we go. So what happens in this example? So we start out with a list, and like I said, our new list only has it only appends items to the end of the list. So when the list is empty, it will become the new head, and then for all others, it will append to the very end. So we're adding the squares of the I of the loop. So we'll add a node with data 0 times 0, then we'll add a node with 1 times 1, a node with 2 times 2, a node with 3 times 3, and a node with 4 times 4. And then when we do the delete node, we'll just be deleting the last node of this list. So we'll delete 16 first, then 9, then 4, then 1, then 0, and we're left with an empty list at the very end. So that's it. It's a fairly simple code, and we can extend it as much as we want. So this really depends on what your application requirements are. So maybe you need to, say, only have head insertion, or maybe you only need to have tail insertion, or maybe you only have position insertion, or something like that. But this shows that if you only need to implement one of these types of insertion or deletion, the code becomes radically or increasingly simplified and very readable. So that's going to do it for this video. As always, if you go to github.com/coffeebeforearch, that's where I have all the code that I use in this and other series, such as the one on MIPS, on Python, on parallel programming in C++, and in CUDA programming, which is GPU programming for NVIDIA GPUs. So if we go to C++ data structures, under the data structures directory, singly linked lists, we have both the one from last time, which is robust SLL, and then this one, the simple singly linked list, SLL, and we have all the code that we used, right? So here we go. Right, there's the main function. Here's the implementation. Oh no, this is the interface, and then here we have the implementation. So yeah, feel free to download this, play around with it, and shoot me a message if you have any questions, either in the comments or right here in the README for C++ data structures. I've got a link to my email as well. So, as always, I'm Nick from Coffee Before Arch, and I hope you had a nice day.